Okay, welcome back. Now we're going to be naming ionic compounds. The only thing you really have to know about naming ionic compounds is the fact that you always write the metal first. I don't know why that's the case, but that's what we do. So, we're going to write the metal first. The only little wrinkle to this is that when you have transition metals, you need to distinguish which charge you have using Roman numerals. For instance, copper makes a +1 or a +2 ion, iron makes a +2 or a +3 ion, and I'm going to show you how to do that in a minute. The best way to learn how to name ionic compounds is to do it. So I have 1, 2, 3, 4. I have 7 here. Lucky 7. So if we look up here, we have the Na ion and the Cl ion. And in order to name this ionic compound, we start with the metal. And the metal is always the atom's name. So we have sodium. All right. So let's start there. Now, the only thing you have to distinguish about the second element is instead of its ending on the periodic table, you substitute "ide." So use the first syllable, and then instead of whatever ending it has, you substitute an "ide." So instead of chlorine, when we talk about it in a compound, it's sodium chloride. This, sodium chloride. And as we move on to the next one, we have sodium. There's our metal name. Now, we went over in the previous video when we talked about polyatomic ions, OH is a polyatomic ion, and that name, or the name of this particular ion, is hydroxide. So NaOH is sodium hydroxide. This compound in particular is very, very common in labs. All right? We use it a lot in our classroom, and especially when we get into acid-base chemistry, we are going to be using this compound quite a bit. Now we have Kf. K is potassium. So we have potassium, and then F is fluorine, but instead of fluorine, we have fluoride. So potassium fluoride. There we go. Here we go. Mg and O, magnesium oxide. Now here we have magnesium again, which is very easy. So magnesium. And then the name of this particular ion, NO3. If you remember polyatomic ion list, NO3 is nitrate. So this is magnesium nitrate. Now as we go through this, we have not indicated how many of each ion we have. And the reason for that is magnesium and nitrate cannot combine in any other ratio other than 1 magnesium and 2 nitrates. It is always that ratio. And because it is always that ratio, we don't mess with the naming. We just keep it as is. Now for our 2 transition metals. It's very exciting. Here and here, Fe2O3 and FeO. You're going to have to use a little bit of logic here because the charge of all ionic compounds is 0. And so we know from the periodic table that oxygen has a -2 charge. If oxygen has a -2 charge here, and there's 3 of them, that means iron has to have a +3 charge because there are 2 of them. Because if there's 3 -2s and 2 +3s, then our overall charge is 0. So once we figure out that iron is +3, then we indicate that charge using a Roman numeral. So in this case, we get iron 3 oxide, and down here we know oxygen is -2 from the periodic table, and there's 1 of them, and we have 1 iron. So if we want to get an overall charge of 0, that means the charge of iron has to be +2. So we get iron 2 oxide. This is how we name ionic compounds. We're going to be doing a lot more practice in class. And in the next video, I'm going to show you how to go from the name to the formula.